This is example 1 of finding the area of a segment. Now we are given a segment of a circle has a 120 degrees arc and a chord of a times square root of 3 feet. And we were supposed to find the area of a segment shaded in the black here. So this right here is the radius, or the radii right here. We don't know the radius because we're not given that. And the one in red is the chord, a times square root of 3 feet. And this right here is a central angle, 120 degrees. The area of a segment is technically the difference between the area of a sector and the area of a triangle. And the reason why it is like this is because the area of a sector, which is this whole thing, consists of the area of a triangle plus the area of the segment. So, it's just a matter of like, take the area of the whole thing, which is a sector, and subtract the one that we could find, the one that we know, and we get the leftover. Well, that leftover is the area of a segment. So that's the way we think about this. So how do we find the area of a segment? Well, let's just write it down first. Now we are given the central angle being in degree form, so we know that. Let's see. So area of segment equal to area of sector minus area of a triangle. But we know the area of a sector when the central angle is given in degree form is 120 degree, the central angle, divided by 360 degree. And we multiply that by pi times the radius square minus the formula for the area of the triangle, which is 1/2 multiply the base multiply the height. So because we don't know the radius and we don't know the base and the height, we know the base, which is 8 times square root of 3 of a triangle, but we don't know the height, so we have to find the height, and we have to find the radius as well. Well, that's when we go back to this figure. Actually, I'm gonna draw it out right here. And we're gonna make use of this triangle to find the height and the radius. So this part here, which is from the chord, which is 8 times square root of 3 feet. And this entire angle here is, I'm right at 120 degree. So this entire angle is 120, okay, not just the left half. So how do we find the height? Well, to find the height, first we want to go ahead and create something called the, if you compare it in this entire shape here, this part is called the apothem, which is from the center of the circle all the way to, perpendicularly all the way to the base of the triangle. So this is called the apothem, and the apothem bisect this angle. So, and this half is going to be 60, this half is going to be 60, and it intersects with the base perpendicularly. So there's going to be the right angles right there. So to find the height of a triangle, we want to go ahead and pick either the top half or the bottom half. So I'm going to pick the top half. So the top half is going to look something like that. Now, as mentioned, this angle is bisected by the apothem, so we know that this right here, this angle, is going to be 60 degree. If this is 60, this is 90, this has to be 30. But then by the 30, 60, 90 triangle property, opposite to 30 degree is the short leg called X. Right? So this is the short leg, even though it looks a little long than this long leg. Opposite to 60 degree is the long leg, and it is denoted by the product of the short leg multiplied by square root of 3. And opposite to 90 degree is denoted by 2 times the short leg. If we take a look at the long leg right here, we know that this long leg is only half of the entire base of the triangle. So we know that we can set this formula equal to the value of the base of the entire triangle divided by 2. Because it is only half of the base. Well, let's see, we have the same term, square root of 3 on both sides, so they cancel out. So we're left with just x equal to 8 over 2, which is equal to 4 feet. Well, if x equal to 4 feet, this is going to be 4 feet as well. So we know that the height of the triangle is 4 feet, like that. So we know the base and we know the height. Okay, that's good then. But then what about the radius? Well, the radius of the circle, which is right here, actually comes from this. I mean, that comes from, is actually this part right there. But this part, which is right here, is given by the formula 2 times x. So we know that the radius of the circle is going to be 2 times 4, which is going to be 8 feet. So this is the radius. Now with the base, the height of the triangle known, and the radius known, all we have to do is that we replace all of the things that we found with their respective values. So replace the radius with 8, replace the height with 4, and replace the base with a square root of 3. Not a square root of 3 over 2, because when we talk about the base of a triangle, we talk about the base of the entire triangle here, not just this top half that we selected from the entire triangle. So to do that, all we have to do is we write area of a segment equal to, well, I'm going to write the formula again. Easy for you guys to see. Which is equals to 120, all right, 360 times pi times the radius square minus 1/2 times the base times the height. But we know the radius is 8 feet. Okay, so to plug it in, well, let's simplify at the same time. 120 divided by 360 is going to give us 1 over 3. Keep the pi, replace radius with 8. Keep the exponent 2. And we know that the base of the entire triangle is 8 times square root of 3. And we know the height of the triangle is 4 feet, so replace h with 4. From here, it's just a matter of algebra. So this right here is going to give us 64 pi over 3. This part right here, let's see. We know 4 times 8 is 32. So we got 32. 32 square root of 3 over 2. But this can be simplified out even more, because 32 divided by 2 is going to be 16 times square root of 3. And that is the answer. 3 square. So the area of a segment is the difference between these two, and I am not going to go ahead and try to crank out the actual value because of the square root of 3, so I'm going to end up with decimal if I were to do that. But yeah, this is the answer of the area of this segment.